Hey, Colfax Math here. Today we're going to look at inverse trigonometric functions and solving for theta given a ratio of sides. We're going to look at the principal value as well, which is a capitalized inverse sine versus a lowercase inverse sine. So let me put the camera over my shoulder and we'll get started looking at principal values. So here's a problem right here. Sine of theta equals a half. What that is saying is sine is a ratio of opposite over hypotenuse. It is saying when my opposite leg is 1 and my hypotenuse is 2, what is my angle of measure? So when my opposite leg is 1, my hypotenuse is 2, what is my angle of measure? This is actually one of the exact value triangles, but if you don't know it, as a 30, you could also do it on your calculator. And before you use your calculator, this theta usually means degree mode. You have to set the mode in your calculator. So under the mode button, I scroll down to degrees. I highlight it, hit enter, so I can quit. So I'm in degree mode. And then the way I solve this problem on a calculator is I can't divide by sine because it's a function. So I take the arc sine of this side, arc sine times sine, they cancel. That gives me theta by itself. If I do that to the left side, I also have to do it to the right side. So theta is equal to the arc sine or the inverse sine of 1/2. That is an inverse function on my calculator here, inverse sine. So I hit second sine of that ratio 1 divided by 2, and I get 30 degrees. So theta's equal to 30 degrees. It's also one of the triangles you should know for exact value, but the big idea is that you understand what's going on here. Theta is equal to the inverse sine of a half is saying given a ratio of sides, what is the angle? So you're really going backwards, versus going forward would be sine of 30 degrees is equal to what? Well, that's saying given an independent variable, what is a dependent variable? What is the y value given x? And that would just be sine of 30 is equal to 0.5. Okay, so I call it going forwards, given an independent variable, find the dependent variable, and then the inverse function is going backwards. Given a ratio of sides, what is the angle? And we can look at that graphically as well. So if my horizontal axis here is theta, and I ask the question, at 30 degrees, what is the corresponding y value? Well, there is only one corresponding y value, and that's 1/2. However, if I'm going backwards, finding the inverse function, and I say, what is the inverse sine of a half? Well, then now I need to draw a horizontal line at a half, and I see the first value is 30 degrees. I also see that there are actually more values, and I know that sine graph is infinite in both directions, and that there will be an infinite series of solutions. It'll be all of these answers, and I need to be able to figure out how to do that. And the first thing I was going to point out is the difference between inverse sine and capital inverse sine. This is one of the things about mathematics, is there really subtle differences or nuances to differentiate things. This inverse sine that's capitalized like this is a principal value, and that's the value your calculator gives you because there is an attached domain to it. The attached domain here for theta would be between -90 and 90, or if you want to look at that graphically, the domain for principal sine is from -90 to 90. And I'll just talk about sine really, but I'll just mention inverse cosine here. Inverse cosine, its principal value has an attached domain to it as well, and it is between 0 and 180. So that principal value's between 0 and 180. So the reciprocal functions correspond with these, and then tangent would be between -90 and 90, cotan between here and here. But let's just talk about the sine principal value. So if the problem is theta is equal to the inverse sine of a half, you just enter that value on your calculator like we did, and theta is equal to 30 degrees. And you're done. That's it. There's nothing more to do. However, if the problem is theta is equal to the inverse sine of a half, there is no domain attached to this, and you need to enter every possible value. So here, theta is going to be a series of answers. The way I do this is I do it graphically, and I think that sine cycles in 360. All right, so it'll do a full cycle right here in 360 with an amplitude of 1 down to -1, half cycle in 180, quarter cycle in 90, and a 3/4 cycle in 270. Now what I'm saying is my y value, my dependent variable, is a half. What is the corresponding value of angle that goes with that half? Well, it's every one of these values, right? And it keeps going on and on and on. So the way I do this is I say when the inverse value of a half is equal to 30 degrees, I put that on here, and that's my first solution, 30 degrees. And then my third solution right here is exactly one cycle beyond my first value. So this one is 360 beyond 30. This one is 360 beyond this one. The next one is 360 beyond that. So I'm going to say 30 plus 360 degrees n. And then n is an integer, and it's the number of cycles away you are. So I could be 20 cycles down, plug in 20 times 360 plus 30, and that would be a solution. So that's the first half of my solution. Then my second half of the solution is this value plus 360n. And the way I do this is I know that there's this line of symmetry here at 90 degrees. And if this is 60 degrees away from 90, then this value here is 60 degrees away from 90. So if I do 90 minus 30 and get 60, I could do 90 plus 60 to get 150. So my second half of the solution is my second value, 150, plus 360n. So again, I'll just recap here. If it is capitalized, it's a principal value. Your calculator will give you that answer, and your answer is 30, a single value. If it's lowercase, it is not principal, and you have to give all possible solutions in a series of answers, and it would be something like this. I find the first one with my calculator, the second one with this line of symmetry, the third one is exactly one cycle after the first, and then the fourth one is one cycle after the second. All right, let me do one more problem. If I could, let me do an inverse cosine problem. And then that'll kind of lay out the basic ideas here, and then it could get a little more complicated with approximate values and radians, but if you understand this, you could go from here. So if the problem is, say, theta is equal to the arc cosine of 1/2, right? So I'm going to do that on my calculator in degree mode. I go second cosine of 1 divided by 2. It's an exact answer of 60 degrees. It is capitalized, so that's it. That's my answer. I'm all done. I enter in my calculator. If it's an exact value problem, you should draw the triangle instead. So your adjacent is 1, your hypotenuse is 2. This would be root 3, and this would be 60 degrees. So if it's exact, find the exact value of the inverse cosine of 1/2, it's 60 degrees. If it's, probably include this triangle to show it's exact. Approximate, you just enter it on your calculator. Now let's look at theta is equal to the inverse cosine of 1/2 a non-principal value? Well, the first answer for theta here is going to be 60 degrees plus 360n, and then I need to figure out this one as well. So let me draw my cosine graph. My cosine graph actually starts up at 1. At the first quarter, it's to 0 on the y-axis. The second quarter, it's at a low space, 180. It's at -1. 270 is back at 0. 360, it's back at 1. And again, this graph just keeps going in both directions forever. So what I'm saying here is the inverse cosine of 1/2 is saying a y value of 1/2. What's the corresponding values of theta that go to the half? Well, it's this value, this value, this value, all these values to infinity in both directions. So I know what this one is because I either know the exact value of it or the approximate value on my calculator. I get 60 degrees. I have that same line of symmetry down the center of the graph, 180 here. And if 60 to 180 is 120 degrees from here to here, the distance from there to there, then the distance from here to here is also 120 degrees. So 120 plus 180 is 300 degrees, and that's my second value. And it'll also be 360n. So the inverse cosine principal value, arc cosine of 1/2 is equal to 60. Inverse cosine of 1/2, lowercase, is asking you for every possible value. All right, there's the bell. Time to go to class. All right, well, I hope that helps on the inverse trig functions. I have principal values. If you have any questions, put them in the comments below, and I'll answer them as quick as I can. Thank you for watching. If you like this channel, think about subscribing.